ensures a clean, transparent administration. The members have a spiritual background. They are popular for nobility and fairness. It is strongly believed that genuine education can never be forgotten. It enriches human character and quality of life. Having established job-oriented courses at degree level and produced world-class professionals, shifted to postgraduate level, MCA, MBA, BEd, and engineering. The society distinguished itself in attaining perfection from its inception in producing distinction and high first classes. The name of KMM is a tip of everybody's tongue. Search for best college and such KMM colleges. So thank you one and all for being this opportunity. Thank you.
Thank you, Smati ma'am, for giving introduction about our college. Now, I request our chairman, Sri S. Srinivasu Garu, to deliver his valuable speech.
Sir, మీరు స్టార్ట్ చేస్తారు.
Good morning, everybody. I am proud to announce that this program today, a one-day national level online webinar on scope and opportunities for electronics and communication engineering, is conducted by our institution, KMM Institute of Technology and Science. I first express my gratitude to Dr. M. Raja Reddy, retired Deputy Project Director, UR Satellite Center, Bangalore, for having accepted with his kindness to address us today on the scope and opportunities for electronics and communication engineering to our students. I appreciate the lead taken by Dr. Krishnaya, the principal of the institute, for having brought up this program today. I am also thankful to Mr. Chandrababu, the HOD of ECE department, Mr. Arun Kumar, the secretary, for having joined today's program. In fact, I am very anxious to arrange such programs to our students to get awareness of their future engagements. Today, engineering is considered to be one of the most sought after career choices for students studying in the science stream. This is because the course allows individuals to develop skills and expertise which are required to lead a thriving career. People should know that India is full of great mathematicians. That is why the engineering subject is popular here. Several other countries invite our mathematicians and engineers for their prosperity. For example, I can mention some of the names which is most required on the occasion. Our great mathematicians are Aryabhatta, Bhaskar Gupta, C.P. Ramanujan, Srinivasa Ramanujan, Chandrasekhar, Shakuntala Devi, C.R. Rao, Prashant Chandra Bose, Varaha Narasimha, Satyavedanath Bose, Harish Chandra, C.S. Seshadri, T.A. Saraswati Amma, and several others. It is high time that our students today are not taking keen interest in developing their skills. It is unfortunate to mention the statistical data gathered that less than 20% get employment in their core domain. It is because of their poor background in the subject. This is a huge loss in terms of manpower and economy. As the world is moving very fast in the technology field, We need to fix the skill of our engineering students quickly to be on par with the world's best countries. Many students are clueless how to prepare, what to study and how to learn in 4-year course. There is an urgent need to make students aware why ECE, what they learn, how to study, what to practice, and where are the job opportunities. You should know who are your employers, what type of jobs are available in the industry, how to prepare to get the dream core engineering job, how to prepare to do undergraduate research and industry internships to get the skills required for core engineering jobs are core topics of this talk. It is proposed to organize this program today for the benefit of our students of KMM Institute of Technology and Science. Once more, I am grateful, sir, Dr. Raja Reddy Garu from Bangalore, who has accepted to present the subject to our beloved students for their golden future. I thank Mr. Krishnaya for arranging this program today. Thank you. God bless you all.
Thank you for your valuable speech, sir. Now, I request our principal, T. Krishnaya Garu, to deliver his valuable speech.
Honorable Chairman, Sri S. Srinivasalu Garu, respected Secretary, Sri S. Arun Kumar Garu, today's resource person, Dr. M. Raja Reddy Garu, faculty members and delegates, a very good morning to all of you. I'm delighted to welcome you all to this one-day webinar on scope and opportunities for electronics and communication engineering, organized by Department of ECE, KMM Institute of Technology and Science. I'm happy to see the delegates for being on virtual platform. When the COVID times, people are worried how to continue teaching learning process in educational institutions. Online platforms coming very handy to us to carry out teaching learning process. KMM Institute of Technology and Science is established in the year 2008. Imparting quality education is the motto of the institution. The focus is to inculcate the continuous learning habit with a positive attitude and ethically sound values within students and staff. The institute allows to further enhance, update, and fine-tune much needed their specific domain skills and soft skills through various training programs and workshops at different levels. Progressive thinking of our management made KMM Institute of Technology and Science stands tall. I thank our chairman, Sri S. Srinivasalu Garu, for his support and encouragement for organizing this program. I thank our secretary, Sri Arun Kumar Garu, who is giving a new direction to the institute. I thank today's resource person, Dr. M. Raja Reddy Garu, retired Deputy Project Director, ISRO-Bangalore, who is my friend and having long association with him. When I approached him for conducting this webinar, he immediately given his acceptance and agreed to share his knowledge and vast experience with the students. I welcome you, sir, and on behalf of KMM Institute of Technology and Science, I will give a brief introduction about today's resource person, Dr. M. Raja Reddy Garu. He joined as a scientist at UR Satellite Center, Bangalore in the year 1986 after finishing his PhD from Sri Venkateswara University, Tirupati. He worked in Power Systems Group of Satellite Center and involved in design, development, manufacturing, testing of power systems for various ISRO satellites. He moved to the Applied Materials Group as Deputy Director and later he worked as Senior Scientist at GE Global Research Center. He also worked as Chief Technology Officer at Aurum Renewable Energy Systems in Mumbai. He visited various countries like US, Europe, Middle East, China, Taiwan, etc. on business meets. He worked as visiting scientist for 1 year at European Research and Technology Center, Netherlands. And also later he worked as Dean Academics, Dean R&D, Principal and Deputy Director at few engineering colleges. He wrote technical papers and published in journals and conferences. He works as editorial board member for peer-reviewed journals and guided PhD students, PG students, and UG students for their projects. Presently, he is working as a freelancer. So, I wholeheartedly welcome you, sir, to this program.
Thank you, sir.
Umundamma.
Thank you for your
Yeah, we have knowledgeable and dedicated and experienced faculty members and head of the department in ECE. They have put good teamwork in organizing this webinar. So, on my behalf and on the behalf of the institution, I congratulate ECE, head of the department, and all the faculty members for the teamwork they have put. We have received more than 200 applications for this webinar from various engineering colleges in Andhra Pradesh. And today, more than 130 students joined for this program. I hope you will have productive session today from the eminent speaker. And I wish you all the best. Thank you.
Thank you for your admirable speech, sir. Now I request our head of the department, A. Chandrababu sir, to deliver his valuable speech.
Thank you, Harika. Honorable Chairman of KMM College, Sri S. Srinivasalu Garu, Secretary, Sri S. Arun Kumar Garu, Principal, Dr. T. Krishnaya Garu, today guest, Dr. M. Raja Reddy Garu, faculty members and students from various engineering colleges, a very good morning to all. Hello everyone and welcome to today's session. Myself, Chandrababu, Head of the Department of ECE, KMM ITS. Today our ECE department conducting national level webinar on scope and opportunities on electronics and communication engineering. There is no field left across the globe where one cannot find the usage of electronic and communication engineering. Perhaps that is why electronics have become the backbone of digital technology. However, as a student planning to pursue electronic and communication engineering courses in India, one needs to walk around and try to see things from all frames. In order to pave a successful career, this webinar may show you a path. Thank you to one and all for giving this opportunity. Now, I will hand over the session to our honorable guest. Thank you.
Thank you, Chandrababu.
Thank you, sir.
Good morning to the young students, faculty members, the principal, and the chairman of the KMM Institute of Technology. 1 minute, I will share my presentation.
Yes, sir. Sir, you can share now, sir.
Is it visible?
Yes, sir.
Yes, sir.
And what about the audio? Is it okay?
Yes, sir.
Yes, sir.
Okay, good. So the scope and opportunities for electronics and communication engineering. I think some of the people can maybe mute their mic instead of having the cross screens.
Some of the students, please mute your phones.
And the mic they can mute, and then they can hear the speaker. So the scope and opportunities for electronics and communication engineering. Why this particular topic? When I used to maybe visit the many engineering colleges when I was working and after also, I used to interact with the students, talk to them. And I used to ask the question that why you have chosen this particularly electronics and communication engineering branch. I used to get the answer, oh, I can get the job in core engineering, also in software engineering. I used to ask them many times, what is the core software and core hardware engineering that you will get? What are the engineering skill set that you have? And what are the software skills that you have to get into the job? It's actually the third year, fourth year students. They are clueless. They don't have any answer to answer the question. I felt that it is better to make the students aware why they have to study this ECE. If somebody asks that one, they should be in a position to answer, explain clearly. And what they learn in the 4-year course and where they find the career and who are your employers, skills that you require other than your basic degree. Many students, they say that we are not getting the internship. So there should be a preparation for internship. What they are, how to get them. Some students may be interested to go for the higher education. So there are the scopes for higher education also. I will wrap up my presentation with the final advice. What engineering? Maybe as Mr. Srinivasalu, our chairman said, engineering is the science skill and profession of acquiring and applying scientific, economic, social, and practical knowledge in order to design and also build structures, machines, devices, systems, materials, processes. So generally, the scientists, we dream about doing great things, but engineers practically, they do it. So they imagine, whatever the imagination they have, that one, they make it to realize. Once they realize that one, they make it to maybe the large scale to implement it, and then see the reality that it is used by the society. After all, that whatever we are doing, that we all are doing only for the society, because society is paying for us. Whatever the services we do, whatever the product we develop, the society will use, and they in turn they pay. Engineers create what does not exist in the world. So you always look for innovation, new things. Engineers elevates the standard of living and adds the comforts of life. So you elevates the standard of living for all the people. This is the engineer's high privilege. All engineers should have maybe a great privilege saying that you have done the engineering and you have learned some of the skill sets that which is required latter part to convert into the product. So why engineering? So many people, they join this engineering because it is easy way to get the job. Second one is to make big money. So how much money do engineer make and what I will get in life? You can have a question there. An engineer is a motivated fellow. In all circumstances and all conditions that one, they are motivated continuously to do the job. Whether it is a difficult condition, maybe whatever the condition that they have, they will do that. And they always see that they never give up. They always see the success. The problems are natural. Failures are common in the process. You have to take all of these things as a learning process and see that you will make it success. You will have freedom to think, freedom to analyze.
Sir, excuse me, sir.
Yeah, please.
Sir, జూమ్ చేయండి సార్ కాస్త F5 ప్రెస్ చేశారంటే స్క్రీన్ ఎలిబరేట్ అవుతుంది.
Okay, is it okay?
నో సార్. ఇక్కడ లెఫ్ట్ సైడ్ ఉంటుంది చూడండి సార్. సారీ, రైట్ సైడ్.
Yeah, the left side. The side, the full window I have made.
Yes sir, yes sir.
Is it okay now? Is it okay?
No sir, PPT.
Sorry. Actually, I have put that one the full screen. Is full screen is not shared?
No sir, side PPT is also visible.
Okay, let me check once again whether I can share the full window.
Okay sir, no problem sir, you can continue sir.
No. If it is not visible that one, then you will have a problem. Is it okay now?
Sir, same as it is only. Sir, now you can press from right side down sir. There is a symbol, full size.
No, see, I'm using the PowerPoint where I have, okay, I will use the...
Okay sir, you can continue sir, no problem sir.
No problem. It is supposed to be visible, no?
No, it is visible, but the side PPT is also visible in sir.
Watch it. I have put that one normal one. What I do is I will go for the maybe the...
Okay sir, okay.
1 minute.
Sir. Sir.
Is it okay now? Please confirm that whether it is okay or not, because I'm not getting the things properly.
Sir, you can continue sir.
Without having a clear clarity, it is not a good thing. I want to make sure that everybody is really seeing the things properly. I put the full slideshow. Is it okay now?
Yes.
Huh?
Yes sir.
Now it is giving full slide?
You have to share, sir.
No, you have to share sir.
I have shared. Please give me a minute.
Okay sir, okay.
There is a problem with the drive.
Okay. Sir, okay sir, no.
Is it okay now?
Yes, sir.
Yes, sir.
Okay. So maybe you have a freedom that one to think, to work, to express your ideas, and also present to the world. Of course, wealth. The engineers are paid the better salary comparatively the all services industries. Unfortunately, the large number of the engineers are going for service industries. If you are working in your core area, you get the better salary, maybe the better opportunities also, because you have to build your career for next 40 years based on the foundation, whatever you have now. So the knowledge, the generally engineers will have the better knowledge. They are very good in numeracy, they are very good in other things, and also technically. They excel in their process. So the excellency is an expected one from engineers, because any product you make, that one, it should have a good reliability, and performance is supposed to be as per expectation. The most important is self-esteem. You have done a job and you have developed something which is useful for the society. So self-esteem there. What and why to study ECE? Many students will have a question mark that one, why I have to study electronics and communication engineering. So you do the technical, technological and scientific discovery when you do the things, and you have a more creative thinking, because your training in 4 years education will provide you the creative thinking. And you work in a professional environment. The professional means those who are working in electronics, communication engineering, professionals. Professionals means expertise. And you will be in a professional environment. And you will have a lot of job satisfaction, because every day that you see the challenge, especially in electronics communication engineering, a lot of challenges, a lot of opportunities. Every work, whatever you take it as a challenging, and see that you do and you complete the process with the great satisfaction. Variety of career opportunities. There are plenty of jobs. Many ECE students, they complain that one, we are not getting core engineering job. First, you see that what is the requirement and what are your skill set, how they match together. In the industry, you have plenty of jobs, but unfortunately, they don't have the good quality engineers with the skill set to meet the requirements. Intellectual development. You become the expertise in a particular area, and that actually makes that one a lot of IP developments. Intellectual property. So whatever the new innovation you do that, you make it a patent, and that will be useful for the society. And your products, your services directly utilized to the society. There is a big benefit to the society. Of course, the best salary depends upon your talent, capability, your analytical skills, and your knowledge in the subject decides that what is the pay packet that you get. So basically, you have all these talents. Suppose somebody asks electronics communication engineering why you are studying, you can say that these all are the various motive things that one why I am studying. So I have put this question mark for everything. So what am I really going to do? So when you join engineering, you may not have the clear idea what you want to do, what you will do. But the same thing will carry till 4th year. But you should have a very clear clarity what you want to do. Because you are at the cross junction, and once you are taken the particular branch, that's all. You never come back. So you have to go in that particular area only. Can I really get there? So whatever the big dream that you have, whatever the big assumption or maybe the big job that you want to do, you always look for that and see that maybe you may be having, can I really get there? But it is possible. If you do that sincerely, it is possible. What are the risks involved? Of course, without risk, there is no benefit. You have to take the risks. So one is the calculated risk. One is the maybe you can assess your capability and take the risk. Am I sure of the route? Whatever the route you are selecting, that one, you can have the question that whether I am sure. Where or and when. So where I will go, when I reach that particular the object, are my subjects appropriate? If I don't make, then do I have any other options? So these are the questions for the every engineering students will have at maybe the first year or second year. If you don't clear maybe by first year end, then the questions will be remain like that for the next 2-3 years. What you learn? You might have studied the basics of semiconductors and semiconductor device physics. So you might have studied maybe the basics, the diode, PN junction. Basically, the PN junction is the one, it works for a lot of things. So you will have the rectifying diode, you will have the tunnel diode, you have the Zener diode, you have the Schottky diode, you have the solar cell. So that's the PN junction. But all will behave differently, though they are the PN junctions. What is the device physics behind that? What you study, how you study. So you will be studying the semiconductor and device physics, because in electronics, the active component is your semiconducting device. VLSA, so it is a very large scale integration. So you will have the variety of the things. Now, if you see that some of the processors, whatever we are using in a computer, maybe i7 processor, close to the maybe 1 billion components that they embedded inside that. So you have the variety of the VLSA opportunity. You name it logics, you name it the memories, you name it maybe the analog, RF, the digital, and then the system on chip and system on package. There are a variety of the opportunities available in very large scale integration. Of course, the many people, they talk about the embedded systems. Embedded system is the product which operates with the software, whatever you develop to do your functionalities. So the embedded systems, generally the people prefer, and most of the engineering, especially the electronics communication engineering students, they prefer to go for embedded systems because both software is involved and also hardware. Any software fellow cannot do the embedded system fully. A fellow who can understand the electronics part and makes the software, that will be the much better comparatively just making the software. Suppose somebody wants to write a code, you have to do the inputs. As an electronics engineer, you know what are the inputs, you know what are the outputs that you require, you have developed your product and you are now developing your software. So you become a master in both software as well as in hardware. So now the present industry needs you require the good software skill sets also. Maybe I will show you that what are the various skill sets that one needs. The wireless communication. So you all are using mobiles. Maybe the many people, many students, without the mobile, the students will not learn. And you have the variety of the spectrum, 3G spectrum, 4G spectrum, 5G spectrum, 6G spectrum. What are these spectrums? What are the challenges involved? So you have plenty of opportunities, plenty of challenges to do the things. The many industries, they look at somebody who is having a forethinking. So you think that one well in advance. The next 10 years, that one, what will be the technology? And if you start now developing your own now, you will be the master and you will be the business leader by the time when it is required and when it is made in the market. The image processing. Previously, we used to have all, maybe if you see the X-ray photography, MRI photography, so other things also. Now what happens, everything is digitalized. And once you take even the blood samples, you can analyze the things taken into the blood samples process. And when I was in GE, I had maybe my next department is the healthcare department. A large number of people, they used to work on the computer programming development, image processing. I had one close friend, I asked him that, what do you do image processing, so many people? He said, a baby boy If you take the blood samples, if you do analysis, we can predict the next 20 years what type of diseases he will get and what will be his health condition. That means the technology is so much progressive, and you can use all your talent to develop some of these the tools which can analyze and use it. Of course, nanoelectronics. So you can see the multi-stacking. We used to have maybe a single PCB board. I don't know how many of you have seen the PCB board. How many people have seen the surface mount technology PCB? How many people have seen that IC processing, how it does? How many maybe, I don't know exactly how many may be aware that how this VLSI and how this nanoelectronics put together, making the wonderful electronic devices now. So this is actually the nanoelectronics also you study. You have analog and digital electronics. So we used to have the analog separately. So analog generally will have the continuous sine wave. In digital, you have the discrete waves, 0, 1, 0, 1, 0, 1 combination. But when you mix together analog and digital, is it possible? A single chip is called system on chip. You will have both analog component, you will have the digital component. As we have studied in mathematics, no, you use 4 arithmetic operators to manipulate the mathematics, addition, subtraction, multiplication, division. Similar way in electronics, especially in digital electronics and also analog, use the FETs, MOSFETs. The MOSFETs is used as a resistor, it is used as a capacitor, it is also used as an inductor, and they do multiple functionalities. So you can have sensors, you can have analog component, you have power, you have RF component, everything put together, and you develop the processes. Of course, now Internet of things. The electronics fellows will play a big role in this. So you have always the team, the software, and also the electronics people. You can see the many things. You can control all these things maybe through some of the control systems where you can develop. So now the people are thinking to go for the autonomous taxi vehicles in the cities. If once you book the taxi will come and stand in front of your house. No driver will be there. And you have already given the destination where to go. As soon as you sit, it takes you to the destination. So they all are autonomous vehicles, but they are controlled by somebody. And you have the autonomous, the controlling system in your vehicle. So most of these things, the electronics people will do. Whatever the work we are working on now, are electrical vehicles. So I do a freelancing work for them, develop some of these the control systems for the electrical vehicles. We use the CAN bus for developing all the protocols, and then the connectivity, the systems, the power, the brakes, then the environment control inside. All the things are done on the dual bus of the CAN. Antennas and wave propagation. Antennas, you might have seen that one, the big. So in our ISRO, we have the one facility very close to Ramanagaram. It's called Bailu. The antenna is a very big one. That is used only to track the lunar satellites. We have Chandrayaan 1, Chandrayaan 2. They used to track with them. Such big antenna. But in our mobile also we have antenna. Some mobiles works at 3G, some mobiles at work 4G, some mobiles at work 5G. What is the difference? One is the processor. Second one is that your antenna. Your antenna also will change, depends upon the spectrum and frequency. So you have the antennas, and so these are basically the subjects I feel that you study in your engineering course. Now where you find your career? So where are the jobs available for electronics and engineering students? We have aerospace industry, both the aircraft and space industry, automotive industry, the construction industry, the defense industry, electronics, there's consumer electronics, the fast-moving consumer goods industry, the marine industry, oil and gas industry, pharmaceutical industry, power generation industry, rail industry, telecoms, and communication industry. Other industries like steel, cement, petroleum, chemical industry, directing, controlling, and testing the production processes. So these are the few area, but there are plenty of jobs available. You know, in India, it is expected very close to the 1.5 million jobs within 5 years. And the very close to the 2 lakh students every year, they come out from the engineering colleges. Out of 2 lakh students, how many are there having a real skill set to get into the job? So we have the jobs available, candidates are less. So your market status, more jobs, less number of quality people are available. So many times we have the complaint that we are not getting the core engineering job. So to get the core engineering jobs, what you have to do, maybe the next few slides I will discuss that. So what are the different roles that you will have in the industry? The different names. Research and development, so where you do the research and develop either process, materials, circuits or components. Design and development, professionals whose responsibility is to design digital analog mixed signal systems, components and part of the systems. So once you design and develop that one, you have to test it. Once you test that one, you will get the results. The results is supposed to be analyzed. So you have to make a comparison with what the specifications define and what are the results that you got. Suppose if you got the results differently, why you got the differently, where is the problem? So you have to identify and then maybe correct it and make it the product the best to meet the defined specifications. Once you develop, test everything, then it will go for the production process. In the production and process that one, you will have the lot of process equipment, the processes, the materials, and different temperature conditions, different environmental conditions you have to do. The engineers will play the big role here. Installation. So once you get the product, that one you have to install. So the electronics engineers, those who are trained and having the knowledge, they install the machines, instruments and parts of at the client location. Once you do the installation, you will have operation maintenance also. So all these jobs, these are I have put that one sequence, but there are many other jobs also available. Core ECE jobs. I have put analog and digital electronics in the top priority because the large number of, in Bangalore alone, we have very close to 1,000 companies are working on this analog and digital electronics design, testing, verification, and analysis. Networking, another big area. A large number of people are working there. So you name it, the Qualcomm, Broadcom, the Samsung, the Toshiba, then the NXP Semiconductor, the Nvidia, Infineon. These are the companies, they are working on networking also. Each company having the networking process, networking products, a Texas Instrument. Signal processing. So many of the equipment manufacturers and also the supporting services. Equipment manufacturers like GE, Honeywell, the Siemens, and the Philips, there are many, Pico, there are a variety of companies, they are developing the signal processing systems. Of course, control systems. You have control systems everywhere. Embedded systems, plenty of jobs. Wireless and optical communication. Defense and aerospace. Now all our broadband connections are on optical communication. The defense and aerospace. Many things, you will name it radar or maybe unmanned air vehicles, spacecrafts or satellites or maybe the rockets or interplanetary missions. There are a lot of electronics and a lot of new things are involved. Power consumer electronics, maybe the switchboard power supplies, and now the transformers are replaced with the solid state devices to make the solid state transformers. So of course, VLSI, digital and mixed signal, this big area. So you have antennas also large number of. So the physical antennas, digital antennas. So there are two types that the way they work. The digital antennas will be the easy to implement in a single chip, so that you don't require any extra antenna. And whatever the space they are leaving for the antenna in your mobile can be used for the screen. So you will have the full screen, 100%. So if you see that screen, that one, the no screen will be 100%. So there may be 80% or 90%. The remaining small part is used for antenna. If you can embed this antenna into the digital, so you can make it 100%. Then the nano electronics and semiconducting devices design and manufacturing. Many people, they do the design part. So whatever the FET, MOSFET, you have the four element, four contacts, the MOSFET will not work for when the technology goes down to the maybe the 5 nanometers or 3 nanometers. You require maybe the totally different type of device. It's called the FinFET. So FinFET also, it is a uniform gate or maybe the staggered grade or maybe the stepped grade. There are different types of things they do that. And basically the silicon is used as a base material to have the devices. But now they are changing to the silicon oxide insulator, so SOI structures. So that gives actually advantage. Atomic layer way, you can model the devices and develop the device which can maybe work much efficiently and with very high frequency operation. So there are non-engineering jobs also. So you can work in a supply chain management. You can also work in procurement and purchasing. You can also work in the patent law and intellectual property. You can also work in logistics, technical sales, marketing, business development, teaching, training, and consulting. So these all are called the non-engineering jobs. They are more on support jobs comparatively the engineering jobs. So there are a variety of companies that they offer a job. In government sector, maybe that's called public sector, you have the Defense Research Development Organization, Bharat Electronics Limited, Hindustan Aeronautics Limited, Electronics Corporation of India Limited, CDAC, BART, DST and CSIR Labs, Indian Space Research Organization, Indian Telephone Industry. Then you have the BHA, Bharat Heavy Electrical Limited, Railways, Ministry of Information Technology, banks and many more actually you have in government sector where they're working with the electronics. Of course, in a private sector, that one you have many. So you can say Intel, NXP Semiconductor, Infineon, then the Synopsys, Cadency. These are the big companies. They develop the electronic design automation tools, where you use these tools for the designing of VLSI, system on chip, or maybe the MEMS, the mechatronics, many things. The Samsung, Lenovo, Dell, Motorola, Nvidia Graphics, Analog Devices, Texas Instruments, Google, Apple, Cisco, Qualcomm, Broadcom, Siemens, AMD, IBM, Cypress Semiconductor, National Semiconductors, Honeywell Automation Private Limited, many more companies. All these companies are operating from Bangalore. They have the offices at Hyderabad, Bombay, Chennai also. But they have the base in Bangalore. These are the small list that you have very close to the 1,000 companies are working. Some of the main companies, some of the service companies, some of the contract companies also. Everywhere there are the jobs, the core engineering jobs, not the service jobs. So what is the skill set that you require to get these dream jobs with the industry where you have? So you need to have a good communication skills. Communication in terms of writing, in terms of speaking, in terms of presentation. So you require to have all three skill sets that one to showcase your talent. Literacy. So when you are getting your degree, it itself tells that one you have the degree. Literacy means that you should have maybe little more skill set, not only the just degree, beyond the degree, the soft skills, how to work in the team, how to do the things. That part also will discuss. The numeracy. So many engineering students are expected they are very good in mathematics. But if you actually see that they are not. If you ask anything, maybe mathematical tables beyond the 10th table, they fumble. They use the calculator to calculate. So you require to have a maybe good numeracy, enthusiasm and commitment. So you should show always enthusiasm to work on that. Teamwork is very important because all the projects are working in the team only. So you'll have the different levels of people, different talents, different skill sets. You have to make everybody work together, and you should be ready to give your helping hand once you finish your job. Ability to turn up on time. So the many times what happens, the engineering students will have the lethargy. When I was working in engineering colleges, my observation I'm telling, I'm not saying everybody is like that, but the many students, when you fix a meeting discussing some of the results, they don't turn up. The next day they come back, they give some fictitious reason. So I had this, I understood that they are telling the fictitious reason. But I want to tell them that one, be punctual and be turn up at the time. If you have not done, you tell that I have not done. If you have done that one, if you have a problem that one, you frankly accept that I have a problem. So we will see that the solutions. If you don't do the thing, if you try to tell some lie, the people will not believe you. Problem solving. The problems are common. You don't have the answers in the textbooks. So when you are studying in your college, you have answers in your textbooks because most of the syllabus is formed based on the textbooks. Textbooks are given to the faculty to teach you. So when they teach that one, whatever you read in the textbook, the same similar type of questions that they will write, maybe 5 years question papers, if you see that most of the questions are repeatedly coming in the same way. So you don't have that problem solving skill set in the engineering students, but you should get this problem. Problem solving means once you get the problem, dissect into the small segments and see that what is the solution for each one. And afterwards you integrate together. Then it will become easy to solve the problem. Of course, IT skills. IT skill doesn't mean only the computer, maybe the Microsoft Office working. You require to have a coding, maybe C++. Most of the electronic students, C++ is the best one. Or maybe another one is Python. You can do both if you are. What you can do is take some problem, so start writing something coding and testing yourself. So you don't require anybody coaching, you don't require anybody training. Your laptop is more than sufficient to do the job. Personal presentation. Many students are having actually the difficulty in giving a presentation. So whenever we ask the students to come to the dais and speak, they fail to come. They hesitate to come. Why they are not coming? So what you have to do is you have to make them to come to the dais and speak. And if you practice the things that when you are relieved from the shy, you are relieved from the inhibition, you are relieved from the hesitations. So you require to have a good personal presentation because now the world is a flattened. Flattened means previously we used to study as a globe, a round one. It is a flattened means that you can see anybody. From here sitting and then maybe talking to somebody in US also is possible. You can work for the US client and if they need something and whatever you have done that one, your results is supposed to be presented. When you are presenting that one, the presentation is supposed to be clearly understandable to the other party in your absence. Of course, customer care. So the timeline, the requirements, maybe you have to excel. You have to maybe finish the job within the time limit or maybe before the time limit. And also entertain the customer that when you are taking care because they are the people, they pay the money for the company. Keenness to learn. The many engineering students, they hear, they forget. They see, they forget. They study, they forget. They read, forget. But learning is a process that one where you should see and it is supposed to be kept in our brain. That's a permanent storage. Whenever you want, you can recollect. So what you can do is take a notebook and write down all the points, whatever you are doing. By reading that points, that one, you should recollect all the discussions, all the understanding, and maybe that makes you maybe more learning process. Self-motivation. So you require to have all the time that one self-motivation to do your jobs. So self-motivation is a very important skill for the engineering students. Now, many students, they ask that, well, I'm not getting the internship. To get the internship, you require, see, the many companies, they expect that you are required to have an industry experience. And you are studying. So you don't get the job without industry experience. Industry experience will not come unless you join the job. So the both are two contradictory. But there is a via media between these two. While studying at your maybe the part-time or full-time, you can maybe join any company to work with the company. So when you want to work with the company, why they have to give you the internship? Internship is not just only giving you an opportunity to work. So they have to give you the real estate, that is the table, the computer, the facility, the AC and power, the cafeteria, other supporting services. When they are spending money, when they are giving you the facility, what is the value addition you bring to the company? So you require to have some of the demonstrated skill sets. What are these demonstrated skill sets that you require to have? So what we proposed is that you start maybe undergraduate research. I have visited the many laboratories, many universities in both the Europe and US. And when I was with the European Space Research and Technology Center, I used to teach the aerospace engineering at Delft University of Science and Technology. I used to take only one day in a week, 2 hours class, that is on Friday evening. And I used to send my presentation by the Wednesday to all the students. And they have the group and where we send. And they go through the things and come there. So most of the times the class is more an interactive type rather than maybe lecturing. So the lecturing is something is not acceptable. What you have to do is you have to maybe make the students to learn more. So here the students can participate in undergraduate research best at second year, first semester. So the first year that you will have the free engineering courses where you go through all the basic things. When you come to the department, the first year, the second year, first semester, then you start forming. So the faculty should have maybe teams. Each member can have the mentoringship for the second year, third year, fourth year. Maybe you can say one batch for 4 students. So totally 12 students that you will have there. And maybe you can propose something, an idea. Either the faculty can propose or student can propose. Once you propose the idea, have a based on details. What you do is when you go for the canteen for tea or maybe the lunch time, put your idea, discuss it very clearly. And once you have the clear idea, and maybe you select one of your faculty members as a mentor, and he can serve as a mentor, trainer, and guide to the team throughout the research process. And what you do is, once you write all these things, go to him, talk to him, and convince that this will be the area. Suppose if he is having a different project, that also you can have a maybe open hearing. Understand the things. If that is the good, that one you continue to work in the same project. So when you work in the project, you see that how much time that you can spare. Accordingly, that you can do that. So every semester, whatever you do, that 6 months time, you will have some results. The weekly, maybe 4 or 5 hours when you are spending for research work. And by the end of the 6 months, that one, you have some results. A part of the work that you have completed. This part of the work, that one, you can convert into a paper. Report first. Writing is actually a great opportunity for engineering students. Many engineering students, they might have studied the English medium from the high school to maybe the engineering, but they fail to write. So writing is a very important point, and that helps you that one to have a concentration Second one is a more learning attitude. So make the whatever the results comes and a small report, maybe 10-15 pages. The same 10-15 pages, comprehensively write a small paper of 3 or 4 pages and present the results with your mentor at various on and off campus symposiums and conferences. Attending the conferences will have an advantage because you have formed a team of 4 members. You have shared the work activity and you did the research and you also got the results and you analyzed all the results with the 4 people and you are going there as a team to present in the conferences. When you go to the conferences, you will have the big audience, the different colleges, maybe the students like you or faculty members or maybe the industry experts comes for that. And you have an opportunity to speak on the dais for the big team. So for this, you will get an opportunity to impress with your presentations to the other people. And also you will get the confidence that what to do, how to do. So another important one is that when there is a question, you take it positively and then answer it. And if you don't have the answer, come back and then maybe prepare it, send it. So sincerely you send it the answer to the people. Take their maybe email ID or maybe WhatsApp or maybe the Telegram, whatever the messenger they have. Prepare and send it. The same work can be maybe submitted to the journals where the peer-reviewed paper. Generally, the peer-reviewed gives the very good feedback for your research work, whether they are in line or not. So if there is any gap that one they will identify, they will tell you that when you please do that gap and then do and prepare the publication. You can seek the reference letter from your mentor for doing industry internships. But all industry internships, they expect a reference letter from your mentor. So benefits of engaging in research is, it enhances the students' learning through mentoring relationship with faculty. Because once you are working with the faculty, you work with very close to the faculty. So that improves the relationship and also your learning capability. Improves the ability to think and learn independently. So you start thinking your own way independently. And you have the question and you have to answer also. There is no answer available in the textbook. So you only the answer. Your knowledge is the answer. Your report will be the answer. It improves the self-confidence. Self-confidence means any work that one given, you will get the confidence, yes, I will do that. So many people, they say that, oh, it is a problem. So if you don't attempt, if you don't do the things, so where is the problem? Problem means there is a solution.